Hello everyone, how are you all? I hope you all are well. So welcome back again. So today we are going to start a new topic that is very important in the board examination also. Solution. Okay, so let's start solution. Solution, basically before starting, what is the meaning of this solution I need to explain. Solution is basically the mixture. It's a kind of a mixture, but a homogeneous mixture we are talking about. Homogeneous mixture means a kind of a mixture where the particles are uniformly distributed. Like suppose if I will ask you to give me the water and then add some sugar in it and make a solution. So what you will do when you will add the sugar and dissolve it, the sugar will be going to be completely distributed equally in all part of the water. So whatever I am drinking, that is a homogeneous mixture. Okay, so that homogeneous mixture of two or more than two component even is known as solution. Okay, so basically what is the meaning of solution? A homogeneous mixture of solute and solvent. So before we start, I will try to tell you the components of the solution. Basically, as already I told you that solution is a homogeneous mixture. Okay, it's a homogeneous mixture of components. Now these components basically we use two. Okay, it's a homogeneous mixture, but it's a homogeneous mixture of components. Homogeneous mixture, again I want to say, homogeneous mixture means the component are equally distributed in whole range of the solution. So that is known as solution, that is a homogeneous mixture of components. Now these components can be more than two, but basically we use the solution, or we use to study the solution where two components are going to be involved. So the type of the solution where two components are involved is said to be binary solution. Okay, it's a type of a solution where only two components, okay, only two components are going to be involved. So it's a type of a solution where only two components are involved, that is known as binary solution. In this chapter we are going to study all the things related to the two components only, that is the binary solution only. So let's see what are these two components. Basically the two components which are present in every solution, that is in binary solution we are talking about, of course, is solute and the other one is solvent. Okay, the two components are going to involve, one is solute, other is going to be the solvent. Now what is this solute? Solute means the component to be dissolved, the component which we are going to be dissolved, and usually its amount is going to be less than other component, usually, not every time. Component which is to be dissolved and its amount is usually going to be less than the other component. Like we can use the example of sugar, okay, like sodium chloride, that is common salt, etc, etc. Many other components can be there, so they can act as a solute. So that is about our solute component. Now moving to the next component, the next component is solvent. Now what is solvent? Solvent is a medium in which our solute is going to be dissolved. As we said already, that solute is going to be dissolved. So it means the other component which is going to be there, it is used to dissolve that component. So solvent is a medium used to dissolve solute. Okay, it's a component which is used to dissolve solute, and generally its amount is going to be more as compared to the solute, generally. Okay, like the universal solvent, we all know water is there. Even we can use alcohol. Okay, for organic solvent we use alcohol. We can use carbon tetrachloride. etc, etc. Many solvents can be there, but usually we use water for preparing most of the solution because water is our universal solvent. So that can be used to prepare the solution. Okay, so when this solute and solvent are homogeneously undergoing a mixture, that results in the formation of a solution. Okay, so that is how the solution is prepared. Okay, so that is what solution is all about. That is a homogeneous mixture of solute and solvent. Now the important thing is that we need to calculate that how much amount of the solute we have added in a given amount of the solvent. So how we can measure it? How we can measure that what amount of the solute I have added in the solution? So basically the thing which is involved here now is a very important term known as concentration. Okay, it is known as concentration. Now what is the meaning of this concentration? Concentration means that it is a term which is used to measure the amount of the solute present in a given amount of solution. Okay, whatever the solution you are having, in that how much amount of the solute we have added, the calculation of that is known as concentration. Okay, like we used to say it is 40% concentrated nitric acid, or 69% concentrated nitric acid, or 98% concentrated sulfuric acid. So what is this? This is the concentration, means the measurement of the substance in a given amount of the solution. Okay, now there are various ways of measuring this concentration. There are various methods to measure the concentration. So we are going to see that one by one. The first is the most important one, that is mole fraction. Okay, this is one of the term which we can use to measure the concentration of the solution. Then the second one is going to be the molarity. Okay, this is again an important term. Then third one is known as molality. Okay, and the fourth one is known as normality. Okay, mole fraction is denoted by capital X, molarity is denoted by capital M, molality is denoted by small m, and normality is denoted by capital N. These are the various methods by which you can measure the concentration of any solution. Okay, if you have to measure the concentration of the solution, we can use these terms. Okay, so what are these terms? We are going to study one by one. Okay, that is about mole fraction, molarity and normality one by one. Actually now these days normality is not usually used. We use only the molarity and molality. Mostly when you used to do the practicals, okay, there we used to measure the concentration, and usually now we use molarity terms. Okay, before that we used to have normality also, but nowadays only molarity we are going to use. Okay, but we are going to study all the concentration terms. So let's see it one by one. Students, now we are going to study the first term to measure the concentration of the solution, that is mole fraction. Now before I start mole fraction, I want you to show you something, that if I am using anywhere the component solute, I will be representing this component solute by B. Okay, okay, that is capital B. And if I am using the solvent component in any place, in any other place, then I will be using the solvent component as A. Okay, so let's study first mole fraction. Now what is this mole fraction? As the name is already suggesting, the fraction of moles. Okay, now as it is a fraction of moles, means basically what we are comparing? We are comparing that how much amount of the solute is present in solution. So we are comparing the moles of the certain component with moles of the solution. So mole fraction means it's a ratio, and ratio of moles of one component. Okay, ratio of moles of one component to the mole of solution, to the mole of solution. Like suppose we have to calculate the xb. Now what is this xb? Already I told you, wherever I am using b means I am using the solute. So basically xb means the mole fraction of solute we are talking about. Okay, so mole fraction of solute means that number of moles of solute, that is nb. Why b? Because it's solute. Number of moles of solute divided by the number of moles of solution. Okay, how we calculate the number of moles of solution? When we take the sum of both the component present in the solution. So number of moles of solvent plus number of moles of solute, when we add them together, it will become the number of moles of solution. So number of moles of solute divided by number of moles of solution is known as mole fraction of solute. Okay, that is how we can calculate. Now when it comes to the unit, there is no unit here because it is a ratio of the same quantity, that is it is a ratio of the mole only. So there will be no unit for the mole fraction of solute or even for the solvent also. Now if you have to calculate the other component mole fraction, that is XA. What was XA? A means we are using solvent. So XA means that we are talking about mole fraction of solute. Okay, so what it will be equivalent to? It will be equivalent to the number of moles of solvent. Okay, sorry, here it is the number mole fraction of solvent, not solute, solvent. Okay, so number of moles of solvent. Why? Because this time we are calculating the mole fraction of solvent, so it should be number of moles of solvent divided by the number of moles of solution, as we have done in the earlier also. In this case, that is a mole fraction of solute also. So XA is equivalent to Na upon Na plus Nb, where again this is the mole of solution and this is a mole of solvent. Okay, now one more thing which is very important. Suppose we consider this equation as 1 and we are considering this equation as 2. Okay, then if you take the sum of 1 and 2, that is we are going to add the two equations together, that is xb plus xa together, then what is going to happen? It will be nb upon na plus nb plus na upon na plus nb. Okay, it will become like this. So when you take the sum, basically when we are going to take the LCM, it will be Na plus Nb, and here it will become Nb plus Na. So both the quantities will get cancelled and automatically you will be getting 1. So what it shows, that Xa plus Xb will always be equivalent to 1. Okay, now this is very important. Why? Because suppose in certain questions, if they are asking about the mole fraction of both the component, they ask you to calculate the mole fraction of both the component, then when you have to use this formula, it will take a lot of time. So if you calculate the mole fraction of one of the component, then other you can find by using this formula directly. Suppose you find xb, then xa will become 1 minus xb. Okay, so it's become very simple. Again, there will be no unit because it's a ratio of the same quantity, that is of mole. So that is the one term, that is mole fraction, which is used to measure the concentration of the solution. Now we are going to see the second term. Okay, that is molarity. We are going to see the second term to measure the concentration of the solution, and that second term which we are going to study is molarity. Very important, molarity. Now what is this molarity? As already told you, that denoted by capital M. Molarity may be defined as, when we comes to the definition, it is defined as the number of moles of solute. Okay, number of moles of solute present in per liter of solution. Okay, whatever the number of moles of solute present in per liter of solution, whatever the number of moles of solute present in per liter of solution, that is known as molarity. And mostly the numerical based on molarity used to come. Okay, and it is the best way to measure. Yeah, generally we can use this molarity to measure the concentration of the solution in the labs. Whenever we are preparing the solution in the lab, we are using the molarity, and whenever we are doing the practical, you will be getting the solution also, that is measured in terms of their molarity. Okay, because when we are preparing solution, basically we are creating the volume of a solution. So whatever the number of moles of solute present in that solution, that is known as molarity. Now there is a formula for it. Now when we say molarity means capital M. Okay, now when we see number of moles of solute, it will be NB. B means solute. Present in per liter of solution means V. Okay, V means that volume of solution. Okay, and this V should be in liter. Okay, so that is molarity formula. Now we can further expand this formula. As you know, number of moles of any substance can be calculated by using the ratio given mass of a substance divided by its molar mass. That is WB we are using, and MB. WB means, WB, if you remember, WB is a given mass of substance and MB is a molar mass of substance. Okay, then multiply by the volume of solution. Now generally what used to happen when we are preparing the solution, suppose I will be giving you and asking you to prepare a solution in the lab. Generally you are having a 500 ml flask beaker, or maybe the 100 ml beakers. So basically when we are making the solution, the beaker volume is going to be in milliliter or centimeter cube. So we are not having it in liter. So if the volume of solution is given in milliliter, then if it is given in milliliter, then it should be divided with 1000. Okay, in order to convert it into liter. So finally the formula will become WB upon MB multiply by volume if it is in milliliter and multiply by 1000. Okay, where again I will say that WB means the given mass of solute, and MB means the molar mass of solute. Okay, and V is a volume of solution, as already told you. So now what will be going to be the SI unit? As it is a number of moles, so it should be mole. Okay, and ratio with the volume, which should be in liter. So mole per liter, or you can say mole per dm cube, or you can say mole liter inverse, or you can say mole dm cube inverse. Okay, so like that you can write its SI unit also. So the unit in which it is usually measured is going to be this, that is mole per liter or mole per dm cube. Okay, so that volume you have to always see whether it is given in liter or milliliter. When we are going to solve some numerical problems, you will find out. So it should be converted into liter. Okay, if it is in milliliter. If it is already given in liters, then no need to write this 1000. Okay, so that is molarity. Now we move to the next term, that is the third term, molality. Okay, molality. Molality is represented by capital M. Okay, so sorry, not capital M, small m. Molality is represented by small m. Now what is the definition of molality? Molality means that number of moles of solute present in per kg of solvent. Two things here are changed. One, that it should be present in per kg, that is the mass is used, and that is true of solvent, not of solution. So mass of the solvent is going to be compared. So moles of solute are compared with mass of the solvent here, and that is the mass of the solvent in kg. Okay. So how we can write the formula of molality? It will be represented by small m, number of moles of solute, that we are going to represent as Nb, divided by Wa, which should be in kg. A for solvent. Wa means given mass of solvent. Whatever the mass of solvent is given, that too is written as A. Okay. So further, if you expand, number of moles of solute can be written as Wb upon Mb, that is its given mass divided by molar mass, as you have already seen here, multiply by 1000. Now why I am writing 1000 here? Because usually when you are getting the solvent mass also, that is Wa, that mostly it should be given in gram. So when it is given in gram, you have to convert it into kg. So for that you need to divide it with 1000. So finally the formula will become like this. Okay. So that is going to be your final formula. Again, I tell you that this is the mass of solvent which is given to you. This is mass of solute, and this is molar mass of solute. Now 1000 when we are using, it means the mass should be given in gram. If it is given in gram only, then only you are going to be multiplying it with 1000. Otherwise you can, no need to write 1000, you can directly use it. Okay. Now comes to the SI unit, as it is number of moles. Okay, that is mole. We are talking about SI unit, mole, and mass should be in kg, so mole per kg. Okay, or mole kg inverse. So like that the SI unit can be used for the molality. Okay, so this is the third term, that is molality. Now only one term is left, that is normality. Now normality we are going to discuss in our next video. Okay, so for today you have to study for the three concentration term, that is mole fraction, molarity and molality. Normality we will be discussing in the next video. So thank you students, goodbye, see you in the next video. Subscribe channel, please share it to maximum.